Great. Great to have all of you in the session. All right. So is anybody else hearing the echo? Okay. Okay. So that's probably there could be there could be multiple Zoom opened somewhere, and because of which it's feeling like echo. Great. Great to have all of you in the session. Before starting, do you have any questions for me? Okay, so VKS is facing a problem with respect to Beautiful Soup. Probably there is a spelling mistake in that pip install. Take a look at the Jupyter notebook where we have written the pip install code. Use that one. All right, I'm trying to adjust my table so that I can stand. Any questions? Any other questions than that? All right, so great. So VKS, you can try the command given by Abhinav, pip install Beautiful Soup 4 without the exclamation. Great, great, wonderful, wonderful to have all of you in the session. And today we are going to use Zoom for our meeting. And this way we will be able to communicate better. All right, all right. So again, hi everyone. Welcome to a session on Python for machine learning course. Today's session is going to be more about the data science and machine learning. as compared to the Python. We are assuming that you are comfortable with the basics of Python. And even if you're not, do not worry, it's not that complicated. You will be able to handle it. Okay? Feel free to ask questions as and when you have a question, and do the things along with me. Do the hands-on along with me, and that's the best way to learn. Okay. All right. All right. So about first of all about CloudxLab, we are making learning fun and for life. So the course comprises of live instructor-led training as well as videos, along with quizzes and hands-on and projects and case studies. And all of these are based on real-life use cases. The automated hands-on assessment is something that we have built and is quite useful when it comes to learning. So it's a for assessments, we provide something environment in which people can do the assessment by themselves. An assessment comprises of problem statement, and you have to do the hands-on in the cloud-based lab. And once you are done with hands-on, the system automatically checks whether you are done or not. Okay. Here is one case, one example where you have to log in and only then this test passes. And here is another example of the automated hands-on assessment. Let me show you. So, all right. So let me just show you quickly what it means by hands-on assessments. Okay. Can you see this clearly, all of you? So here on this side, these are the challenges provided by the system. It is saying that create a variable myInt with a value 20, create a variable myFloat with the value 15.0. It should be a float variable, and create a variable myString with the value hello world. And fourth challenge is to define a boolean, and then it's asking you to define a function myMax to find the maximum of two values. Okay, so when I click on I'm done, please check. It's checking and saying that you have not defined integer at 20. So let me just define only the integer by pressing Shift Enter. So we are using here also, it's basically a Jupyter notebook. So you continue to work in Jupyter Notebook and the system checks you. So here it's asking me to define a float. So I execute this statement. Now it's asking to define the string. Let me just finish the string as well as the Boolean variable. And then I'm defining a function myMax, which is returning the max value. Okay. All right. So you see that it has done the the checking of your work. Okay. So um, it has successfully checked whether whether you have done it or not. So what you see here is in case let's say you are defining some other parameters. It doesn't matter what parameters you define, but if you are defining if your logic is wrong, let's say this is the logic. In case this is basically returning the min instead of max, it's returning the min. So it's saying that define a function myMax to find maximum of two variables. Right? And so basically it's checking the input output of your function. So this way, we practically can design all kind of challenges while you are working in the Jupyter Notebook. All right. Um, a question is, will you teach class also? Yes, Binta, I will. I will be teaching the class also. Okay, so this is an example of the assessment, and there are similar exercises that you will have to attempt. For example, here you have to define, you have to compute the area of rectangle, and here it's asking you to do these steps. And once we are done, only then it'll give us go ahead. Okay, the test will pass only if we are done. Okay, there are quite a few exercises in which you can there are quite a few exercises of various kinds which checks whether you have learned a concept or not. Okay, so this is something which we are working on, and these questions will be available soon in my courses of the Python, probably by end of today. In your courses, when you go to CloudxLab, here, when you go to my courses, here you should be able to see the exercises inside Introduction to Python. Similarly, in the Linux part, we are trying to teach with respect to the various Linux command, and this is actually very exhaustive tutorial. If you are trying to refresh your knowledge of Linux, or you are trying to learn from the beginning, this tutorial is pretty good. It is just that it is not video, it is mostly text, and it checks whether you are doing all of these steps or not. Moving files in directories, moving files in folders, all of this, there are tests involved which basically checks whether you are really doing it or not. Okay, so we will be soon embedding the same editor here also, the one that we have done for the Python case. And in this one also, we will have the similar cases. So the idea of most of the courses is that the learners should do the hands-on, only then they will learn. And the checking of hands-on should be instantaneous. It should not depend on human intervention. And that's the only way individual will gain confidence in the technology. All right. Great. So this is what we have been working on, and we are going to make it available maybe by end of today or by tomorrow. All right. So that's what is hands-on assessment. On the left-hand side, you are given a challenge. On the right-hand side, you solve it. And similarly, when you go to the next, it could be a video, text, or it could be an objective question or fill in the blanks. So we're working on all kinds of assessments and exercises so that a learner could build, learner could um, learn and practice at the same time. Okay, great, great. The objective of the course is learning Python for machine learning and deep learning. This is basically the part one of our machine learning specialization. Machine learning specialization comprises of machine learning, deep learning, and foundations of Python. Okay, today is the last session of Python, and today we are going to study the basics of objects, NumPy, SciPy, and pandas. We are not going to cover SciPy because that's anyway covered in NumPy. So we are going to talk about NumPy, pandas, and how to plot graphs and charts inside of inside of Python using Jupyter. Okay, so we are going to learn all of that today. All right, so I'm Sandeep Giri. I graduated from IIT Roorkee, worked on large-scale computing throughout my life, and um, the I started my career at D Shaw, worked within Mobi and Amazon, and at all these three places, the work was either related to the machine learning or related to the high performance computing. And I'm a software engineer at heart, and I love explaining technologies to colleagues and friends. And we I started No Big Data, and then we renamed it to CloudxLab. So the sole objective is to help people learn effectively. And by the end of most of our courses, we have been able to successfully impart knowledge which is usable. And for questions, come over to the discussion forum or reach out to us at reach@CloudxLab. All right. So that's about us. So this course, this Learning Python course is free and for all. And the machine learning and deep learning, the introductory session of machine learning and deep learning is going to be available to everybody. The introductory session will be free for all, in which we will cover the landscape of machine learning. And the introductory session of machine learning is going to be December 3. And there we will basically go over the landscape and understand the meaning of machine learning and the various use cases, and if possible, we will try to demo a real use case. Afterwards, we will start with the actual machine learning. Again, just after the introduction of machine learning, what we are going to do is we are going to do end-to-end project. Okay, that sounds strange, but what we believe is that you would learn by doing hands-on better. So the way most of the programming languages or most of the technology should be learned is practice, theory, practice. Okay, it should not be theory followed by practice runs. It should be we start doing things upfront. Say when we had to learn Python, we started just writing simple 2 plus 3, right? And rest of it, we will automatically figure out when I say where there is a variable x to which we are assigning some value. If you have already done x equals to 10, the sentence will make more sense to you as compared to just the theory. Okay, so my experience is my experience is when I was teaching a team of really senior people at IBM was that um, I taught for a week. That those were my beginning days. I taught for a week, and then next week what I did was I conducted a quiz in which I asked them all questions, and even though while I was teaching, the class was really well engaged. They were not, they were paying attention and they were also responding to questions. But after a week, they only retained the part which they did hands-on on. Rest of it, rest of the things that they listened to and they understood, they could not retain. And these were really senior people and really um, successful people in their career. These were a very senior team at IBM. So my learning was only the parts which people do hands-on along with asking questions, or the parts where they get stuck and they try and you know solve those problems. Only those parts you will retain. Otherwise, rest of it, whatever theory you will listen in the class, you are going to forget in maybe a week or so. Okay. Okay, so Binta's question is, does December 3 refer to PST on Sunday? It is going to be December 2 in PST. Okay, it's going to be Saturday in PST. Okay, December 3 is with respect to the IST. All right, so that's why we decided to do a lot of hands-on. Great. So we have talked about this part, and okay. Now coming back to what we were talking about. All right. So all right. So yesterday we were talking about something with respect to the network. I'll talk about that now. Great. All right. So far what we have covered in these sessions is we started with the normal Python for machine learning. We talked about how to install using Anaconda. Then we use Jupyter out of Anaconda, and then that's what we have done so far. And the we talked about expressions, conditions, functions, iterations, strings, files, and lists, and everything. Okay, those who are looking for the link for the GitHub repository, here is the link for the whole folder. So we have talked about part one. Part two is something we are going to continue today, and then we are going to talk about NumPy and pandas. Okay, let me share with all. Okay, now it must have gone to everyone. All right, great, great. So in this, you will find all the notebooks, and notebooks is probably one of the best way to learn anything related to Python or any other language, because notebooks are available. You can do a lot of other things in Jupyter other than Python. You could do Scala, you could do Go, you could do even console, and so on, right? That's one of the reasons why we have embedded Jupyter in our assessments. Okay, because you can practically do almost everything with Jupyter. All right. So yesterday we had left one part, and Prasanth's question is, does this contain some exercises for us to solve or practice? They will appear in your My Courses soon, by end of the day today. Okay. All right. So let's start where we left yesterday. Yesterday, we when we were talking about the networking, there was one part that we did not cover, and that part was the SCTP request using sockets. So socket is a low-level library in Python, and when we want to connect to a server, we use socket. Okay, and using socket, we can communicate with any kind of service. Okay, it any kind of service. So here, what we're doing is we are importing a module called socket. We will discuss more details about module, and then we are creating a socket, and afterwards we are connecting to this server at this port, and then we are sending this. Yesterday we were not using B here, okay, B for binary strings, and this basically, and the other part that was missing there was this section. We were not mentioning the host this way. Okay. Now you can see that when we have sent this request, and here we are iterating indefinitely, we are reading 512 bytes at a time, and uh, and we are doing it till the length of data is positive and greater than 0. Okay, in case the data is 0, the length of data that we received is of less than 1 length, we break here and we print that data on the screen and close the socket. Okay, that's what is happening here. So all right, so you can see that we are receiving, first of all, we received this header saying SCTP 200 OK, right? Now 200 you may not be aware of, but you may be aware of 404, right? 404 is error message, and here it's 200 means everything is okay. And then we are getting the information about what kind of content it is. This is part of SCTP protocol, and we also receive the content length. Afterwards, we get the other details like time, and we also get the last modified date of the page and so on. Okay, and here what you see is here, this is the data. So till here, this is the header, and from here, this is the data. Okay, and this one is nicely formatted here. All right, a question is, what does this particular line mean? Okay, we can open all different kind of sockets. Here we are opening a particular kind of socket, and we are saying that we are opening it over sock stream. Okay, so this is kind of I don't want to go into more details about it. There are different kind of streams, and there are different kind of mm, the the I internet protocols, and we are just using the INET protocol right now. Okay, and what it means by 512, here we are saying that read 512 bytes in at a time. So instead of that, we could also say read 1024. Okay, and still we will get the same results. Okay, these are the number of bytes. How much is byte? 8-bit is a byte. Okay, and we are reading 1024 bytes at a time. If we print data here, okay. Oh, we are actually printing data every time. Okay, so we can also print things like, and if we are just receiving, say, 50 characters at a time, this is how it's going, or 30 characters at a time, this is how it's going to look like. You can see that? We're just reading 30 characters at a time. So Tanmai's question is, shouldn't we have a try-catch block here? Of course, that's a very good point. So we should have a try-catch block in this. Okay. So instead of reading the entire content in the raw low-level socket, what we do is we read small bytes at a time, and then we print that on the screen. Then we access it and use it in howsoever way. Okay, great. So All right, so this is something that didn't work yesterday. We were missing B here, and we were not supplying the host name. Okay, great, great. Now let's continue a new topic today called Python objects. Okay, so Python is an object-oriented programming language as well. Python provides you functions, ability to call functions, and everything that any other programming language provides. In this, but Python also provides objects. It's going to be more about definitions today, and more about how it works and less about how to use it. So you must try creating objects, and then you will get an idea. Okay, so in this course, what we are learning is we are going to basically learn the basics of classes and objects, because data science does not require too much of object-oriented programming. Okay, so we had learned the data structures earlier, like we had list, we had dictionary, and so on, and list provided these methods, right? So these were basically objects. These were basically the classes of which we were creating objects. And if we are using, say, SQLite or some third-party database, they also provide the objects and classes. Okay. Now, yes, question from Tanmay is, do we have finally block in Python? We do. Okay, we do have a finally block. All right. Now, take a look at the try catch code example. All right, good question. Moving ahead, so let's take a quick look at what we did earlier. The first program that we wrote was, we took the input from the user, and then we converted, then we subtracted one from it, and then printed it. And of course, here we also did a conversion from string to integer. So we took input, we processed, and we gave output. That's what we did earlier. Now, in case of object-oriented, typically the program takes input, does something, gives output, right? That's what a program is. In case of object-oriented, a program is made up of many cooperative objects. Instead of being the whole program, each object is a little island within the program, and cooperatively working with other objects. A program is made up of one or more objects working together. Okay, so that, and basically what we do is we break down our program into these objects and classes which interact with each other. An object is a bit of self-contained piece of code and data. An object is a self-contained piece of code and data. You remember dictionary? Dictionary was, what was it? It was key and values, right? It was containing data, but it did not contain the logic or functions or code. So a key aspect of the object approach is to break down the problems into smaller understandable part and then use them. So object provide us these boundaries that, like in real life, what goes within a particular system should not be a matter to the users of that thing, right? As long as it is giving the desired output. So that details are hidden from the outside. Okay, so here is an example of a list and a dictionary. We're creating a list, we are creating a dictionary, and movies is a list and movie one is a dictionary. We are defining a movie one and appending this movie one to movies. Then we're creating another dictionary of movie 2. And movie 2, we are putting the director, title, release date, running time, and ratings, and appending that to the list. All right. And then we are iterating over the movies in the keys. Okay. And printing it. So basically, your program looks like this. It has here we have keys. Here we have list of movies, and each movie is a dictionary and is an object, and there is a string and so on. So objects get created and used, and you get output. Okay, so each of the parts is code and data, and they're interacting with each other to give you the results. All right. So a quick, again, a bit of definition. Class is a template like dog. Method or message is a defined capability of a class. Say, for example, dog can bark, right? Fields or attributes, a bit of data in the class like height of the dog or length, or object or instance, a particular instance of a class like lazy could be a dog. Okay, there could be many dogs, but the template of dog, the definition of dog is that it can bark, it has a height, and so on, right? So like a person has features and everything, but Sandeep Giri is a person. So Sandeep Giri is an object, while the person is the class. Okay, I'm going to skip this part. And the instance is basically creating an object out of a class. All right. The method is basically just like a function, normal function, which can operate upon the variables of a class. Okay. Here is an example of a, a class. The way we define a class is by the way of saying class party animal x equals 0, define party. This is one function that we are defining inside a class. Here, the first argument of this function is self. Self means it points to that object, that current object. And self.x means this variable equals self.x plus 1, and then we print it. Okay? We are going to give you a quick example of this. Package maybe after a while, or here. So you can see that the it has printed this. Now let's go ahead. Now let me increase the font. Great. Okay, so all right, so what we have is a class called party animal. Here we're defining x as a variable, and we are defining this method which is inside this class. Okay, this method will be available on the object of this class. And how do we create an object? Like this. Okay, so this party is just a method. A question from Tanmay: where is the constructor? Constructor is not here defined now, but we can define our constructor later on. So Python does provide a constructor, but it is not mandatory to define the constructor. Okay. All right, so I hope this code is clear. Self.x means, self means the current object, and dot means the member of this current object, and x means this. Okay, so if there are And once we have defined this class, we can define as many objects of this, right? So here, let's say I'm going to use this here. First, let me define this. Okay, so we just defined a class called party animal. Right now, there are no objects of it, meaning meaning we can use it. So you can see. So as and when we are calling this function called party on this object, the variable is increasing, right? Because this is what's happening. So when we call party, this method x is going to increase. But if we define a new object of the same class, let's call it, okay, uh, someone. Okay, I call it someone, and someone dot party, right? Someone dot party, and you can see that for someone dot party, the value is 1, while an dot party, the value was 3. Okay, so this way we can define an object, a class, and then use it. So you can see that the value of x is different for different users, different for different objects. Okay, let me print here saying, right, this is, let's say, someone, and this is, okay. So you can see that the variable again starts from the beginning for another one. And if you call the the previous one again, let's say we call this one again here, what would happen is it'll continue from there. Okay. Okay. Question from Tanma is that uh, X is private or public? X is actually public by default. So you can see that you can use this easily. Okay. A question from Abinda is that what is the function of X? X is just a variable. X is just a member variable, which could be, there could be hundreds of such variables inside a class, and you could use them from outside. Okay. So when we have to create our own data type, the other way of looking at a class is when we have to create our own data type, we can create that using class. Okay, like people have created lists, people have created dictionary, and so on. In the similar way, we could create our own data type having the functions and use them whenever required, right? All right. Um, Question is, what if we defined here like x equals 8 and then run it? So, sorry, not in this one, the previous one. So let's say we defined 8. The beginning value of all of these will become 8, right? So it started from 9, 10, 11, and then the second object 9, and the first object increases to 12. Okay, after 11. Is that what you meant to ask, Binta? Yes, this is the initial value of x. There can be a constructor as well. Okay, we'll talk about the constructor later. All right. So now, once we have defined our objects, we can also check for their data type. Okay, check for the data type. And here, when we say type of this object, or let's say type of print type of so, or print type of n, right? The You can see that the data type of both is party animal, right? So the way we used x equals dictionary, dict is what we use to create object. In the same way, we can create our own objects, okay, our own classes and use them. All right, so that's what it means by a class. Class contains variables and class contains functions. You can create many objects of class and use those objects without touching each other's data. Right here, we are not touching each other's data. Both of the classes are maintaining their own variable. We can also look at the functions of the class using dir. And if you say dir n, right, dir n, you'll see that there's a method called party and there's a variable called x. Okay, now question is the constructor. If you want to define a function which gets initialized, which gets launched when we are creating the object. Okay, when we are creating the object, if we want to create a function, sorry, let me break it down. Okay, so this is how we are defining the class. Let me separate the use and the class. Okay, so here there is another class called party animal. It has a variable and it has the constructor. What is constructor? Constructor is nothing but a function that gets called when a object of the class is created. Every time somebody is trying to create an object, okay, okay, it is going to be called. Okay, so we could write some more things here. Let's say I'm writing a party animal is born. Okay, so that's what the function is. And let me just define this class. And every time I'm going to call this, right, it says that I'm constructed a particular party animal is born. Okay, and when I do that for another object, when I do that for another object, then again, it's going to say the same thing. All right, so if you want to do something magical, um, such as initializing x equals to say some random number, okay, some random number, then also we can do that if we want to initialize something. Also, if you want to do something at the when the object is destroyed, what does it mean by object destroying? Object destroying is called when object is no longer used and Python chooses to delete that object. Then this function is going to be called. Okay, so it has constructors and it has also the destructors. Okay, so the when the object is deleted, this is the function that gets called. All right, now we can create many instances of the class that we already discussed, and we can take argument in the constructor. Okay, in the constructor, the first argument is the default, the argument itself, and we can take the name as the argument from the user. So let's say here we have the name as the argument, so we can pass that while creating the object. Okay, so you can see that here what we are doing is we have taken the name in the constructor, which means this while creating the object, the default value of the name is going to be from the argument. Okay, and when we call party, it's going to print this. Okay, it's going to say Sally party count 1. It is uploaded on the GitHub. You can take a look. I have not changed much. Okay, I have not changed much. Let me just git push. No, there was another one. Yes, git commit and push. And means it will commit, and then once commit is successful, only then it will push. Okay, so I've done that. All right, so great. Great. I've kept it on the GitHub repository. You can use it from there. Wonderful. Wonderful. So what we learned was we can define the constructors. We can take arguments in the constructors like the way we are passing these values. And we can also have something called a destructor, which gets called when when the object is no longer in the use. All right. Now, in the classes, sometimes what happens is we realize that our class can be created by extending the existing class. Okay. In those cases, we can inherit as well. The way we inherit is by passing the name of another class in the argument. Okay. And basically, football fan will have all the functions of party animal plus one more. Football fan will have all the functions of party animal plus one more. Okay, so a class is nothing but bunch of functions and variables in it, and it behaves like a data type in itself. Okay, we can create as many objects as we want and use them like the way objects is nothing but a variable of the data type of a particular class, right? So it just objects is nothing but a variable of a data type of class, right? Like the way we had defined X and so on. Okay, no worries, Manoj. The recordings will be provided to you. So we were just quickly going over the object-oriented part of Python. Even if you skip object-oriented part of Python, it will be completely okay for the machine learning course. All right. So this is how the inheritance works like. Okay. So here we can see that the football fans object is J, while party animals object is S. On S we can call party, but on J we can call both functions party and touchdown, not tear down, touchdown. So if we try to call touchdown on this, on the party animal, it's going to throw an error, right? This is good, but it says there is no method called touchdown. Why? Because the parent class does not only has these methods. This is the constructor, meaning the function that gets called whenever we create an object of this class. Okay, so as in when we call this is the way we create an object of a particular class, and as in when we call this party animal, this constructor is called. This init method underscore underscore init underscore underscore. This is how you define the constructor. All right. Okay. Now let's take a look at the destructor. Destructor is like this. Destructor is underscore underscore del underscore underscore. All of the functions of a class must have self as the first argument. Okay. So while you're calling n dot party, it's basically calling this method with an in an a reference to the object itself. All right. So this is how you define, you do the inheritance in case of Python. All right. So you can see that we are able to call these two methods, right? These two methods on Jim, but on Sally we are only able to call party. A question from Tanmoy is that can we call this? Not really. Not really. This way, if you see, this is how we used to call in Java. Now, the basically in case of Python, we don't need to define the data type of an object without a value in it. Okay. All right. So probably your question is, can I convert one object into another? Of course, because because by default in case of Python, we are not trying to assign one data type to another, right? Therefore that actually casting becomes further easier, right? In case of Java, we had to define a variable data type, and only that kind of data type would fit in there. But in case of Python, that's not the case. In Python, when you assign something to some variable, the whole value gets overwritten. Okay, so if you have, let's say you have uh, an array of S and J, right? You could in a loop call print x dot party. Okay, if you had this, let me just comment this out, comment this out, comment this out. We could call this. You see, Sally get constructed, Jim constructed, then Sally party count 1, Jim party count this, and you can see that we are able to iterate over different kind of objects comfortably. Why? Because party method is in S, party method is in J. Make sense to you? So this way, this is how the polymorphism looks like. Polymorphism means uh, something behaving like many things. Here, J is behaving like J is having the party method as well. So J can behave like a party animal as well as football fan, right? Make sense to you? So that's pretty much about the modules in Python. Sorry, that's pretty much about object-oriented programming language in Python. All right, going back again. So we can create our own data type, which can have its own methods. Okay. And the way we call it is by using, by calling this class like a function. Okay. So party animal, the general tendency is the way we define the name nomenclature is that the name of a class is generally capitalized. All the nouns or all the words have their first letter capital. Okay. While in case of functions, we generally prefer a syntax like this. All of the letters small and underscore and then another word. Okay. So that's kind of convention in case of Python. It's not really required. You can have any kind of name as long as name of the variable or a class, as long as it doesn't start with a digit and it's made up of digit and alphanumeric and underscore. Okay, that's the name of the variable in Python can be anything alphanumeric and underscore, as long as the first character is only is not numeric. Okay, so the same naming convention applies for variable name, function name, class name, and so on. Okay, now, so we talked about how to use the variable name. We could also check the data type of a object, and we could also list the methods of an object. All right. And somebody has raised, yes, Vikas, you have raised your hand. Is there a question? All right, good. Now, moving ahead, we could create these special methods, which will be called when the class is constructed, and then when the class is constructed, we could define these methods. Okay, and I also showed you that we could create multiple objects, and the variables of objects will not interfere. The x for first object will be different from x for second object. The values will keep isolated. Okay, and then we talked about inheritance. To inherit a parent class, we could use this. Okay. All right, so that's pretty much about object orientedness. A question from Tanmay: how to declare static variables like Java? How to define static variables like Java? Mm, I don't think Python has static variables. I'm not sure. I've not used a static variable in Python. And most of it, whatever static variable provides you, you can generally emulate it using the normal variables. Yes, Binta has a question. Question is the first function in the class init and with the name of the variable self? Okay. So first function does not mandatorily need to be this, and this does not need to be mandatorily the first function. As long as there is a function with the name init, that means this function is going to be called whenever we try to create an object of this function, object of this class. Okay, so as long as the constructor is named underscore underscore init underscore underscore, it will be called. Okay. Now the second question is, what about self? Self is nothing but the reference to the object itself. Therefore, by default, all of the functions must have this self variable. Okay, just try to create another one. It will allow you creating, but when you try to call it, it's going to throw error. So let's say I'm trying to create a function like this and do something here. Okay, and when we call this, so it is saying indentation problem. I will just fix it. Just copy this indentation because that. All right. When the indentation is not equal to the previous one, then it throws error. So you can see that let me just remove this part. In Jupyter, you can just say control slash or command slash in case of Mac to comment out things. Okay, so if you try to call this method called pp, it is going to give error. You can see that pp takes 0 argument while 1 was given. That means internally when we're calling this, it's actually calling pp with an argument called self. Okay, and therefore we must define the self if we want to call this method from outside. If you are just calling this function from from another function, let's see if it works. Okay, and you can see that the pp is not defined. See that? We'll have to call it using self.pp, and then it'll throw an error saying that that method does not support self method. Okay, so the important part that I'm trying to show you is that while defining a method, a method in a class must have at least one argument called self. Okay, the first argument must be self. All right, but the init method can be third or second or any number, but the first argument for the function should be self. I hope that answers your question, Binta. Question from Pavan: how GC works in Python? Can we call destructor in the code? Yes. So I'm not sure you can call the destructor in the code, though it allows you calling the method. Good question. Question is, how does garbage collector work in Python? And can we call destructor in the code? So you can definitely call a destructor in the code. The only problem is that it is going to give you wrong results. All right. So what does it say? It says that this method is not existing. Let me define again. All right. So coming back to it, the destructor part. This is the destructor. Destructor is automatically called when the object gets out of the picture. All right. So yes, first argument should be the function and must be the self. Does it apply to all functions in the class? If you want to use those functions, okay? At calling time, it will give the error. It will not give the error at the defining time of a class. Okay, great. So I think that will be pretty much with respect to the objects and classes. All right. All right. So now let's talk about modules. Already we imported some of the classes like socket and other things. Those were the modules. Okay, what is a module? Module is the piece of code written by somebody so that others can use it. Okay, you install modules using pip in Python, and there are few other ways to install module. There are quite a few modules that come out of the box with Python. Some of the examples are random. Random is a collection of functions. Random is a collection of functions and classes that has the methods related to generating random numbers. OS gives you this ability to interact with the operating system. Say, for example, you want to iterate over all the files in a folder. That you can do using OS. With OS, you can also call, there are methods to let you call any of the operating system's command. Then there was a module called RE for regular expressions. Then there is a module for date time. Using date time, you could interact with the system date time and also manipulate the date and time. Then there is math. Some basic mathematical functions are provided here, and XML basically, and if you have uh, you know, if you have XML data and you want to parse it, load it, you can use the XML. If there are modules for almost everything. Why we are studying Python is because Python is probably having most modules for various kinds of works. Okay, the reason why we chose Python was because the machine learning libraries such as scikit-learn and TensorFlow are available to us, as well as it is really simple to use. Okay, so that's the reason why we chose Python for our work. Now to take a look at the functions provided by a module, we could say dir. Okay, so here we're trying to show you the list of files, and when we do that, it will show me the list of files in my current directory. You can see that the files from my current directory are listed. These files, readme and others, are listed. Okay, now when we call random.random, so whatever name you import it with, it'll be, these functions will be available like that. So here when we say random, the random.random will be available to us. All the functions of random can be called. Okay, so and here are the, when we say dir datetime, it will list all the functions of a module. All right, now moving ahead. So yes, no, it's getting recorded, no worries. So we are just talking about modules. You can import modules using import method, and you can do dir on a module to take a look at the functions inside it. So when we say import random, there will be a variable random available to you in your code, and on that we can call the methods inside random. Say when we say import OS will be made available to you, and you can call methods on it. All right. So question from Dinesh, this is giving error. Okay, okay. So maybe you could try in Python 3. All right. So in the module, let's try to do something. I'll try to create a file. I'll try to create a module for let's say this. Let's say we have come up with this wonderful library of computing interest. We have defined a function which does the simple interest, as in multiply principal with the rate and the time and divide by 100 and return the value. And then we have defined the compound interest, which takes 3 arguments and computes the compounded interest yearly. The t that is passed is number of years, and once we can, so we can just check if it is working fine or not. Yes, it is working fine. So now what we can do is we can create our module using this. Okay, let's say I want this to be separated out so that I can use it in many places, and if I make any modification improvements to this, everybody will get the updated functions. Okay, so there will not be a duplication of code, and we will be able to use it. So what we are going to do is we are going to create a file called mylib.py and copy paste this piece of code into that. Okay, so here is my file. So I could delete that, right? So here is my file. Let me just delete it so that I can show you from the beginning. What we're going to do is we're going to create our own modules quickly, just to give you a good idea about the meaning of a module. Okay, so can I delete from here? I don't think so. And what does this delete mean? No, 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 no. Are you sure you want to delete 2 files / folders? No. Okay, I'll just delete only one. Okay. Now, then I'm going to create a text file. Okay. And copy paste this piece of code. Okay. This piece of code here. So the name of the file is going to be mylib. You can keep anything. Okay. You can keep anything. Good. So now we have, created this file called mylib here. You see that in my current folder. All right. In the code here, we can simply import this module that we have just created. And the functions of mylib are going to be available like this, mylib.compoundInterest. Now you can imagine what it means by OS. OS import OS means there would be a function called os.py containing all the functions. Okay, so this way we can create our own module and use it everywhere. Is it clear to everyone? All we did was we took this piece of code, put it in separate file called mylib.py, and since it was in the same directory, we were able to import it. Had it been in some directory, then we will have to call it using the directory dot that folder name. Yes? Okay. So what we learned was, yes, Prashant, you have a question for me? A question from Kamal, can I see the source code of any library I import? Yes, of course. Okay. Because, all right. Yes, first of all, the easier way would be just to search for Python source code online. Most likely you're going to get the in the GitHub, and that would be a better way to do it. Second, and in the local file system, you could take a look at the Python path, and what you have to do is you'll have to find where is the module located. Okay, and then it will help you out with respect to understanding. So you can actually, there would be a method on the module or there will be a method on the module that will print the location of a module, okay, on the file system. And using that, you can go to that place and do that, okay? There must be a method on the module. You can try dir. So if you say dir, let's say OS, there would be a method on a module or dir mylib. Or can I do help mylib? You can see that it is located here, right? So if you say help OS, right? If you go to the bottom, it is going to show you that this is located here, right? At this location. And then you can open that. Right? I'm not sure. How can I quickly see a file using Jupyter? Can I use %cat or something? Okay. Question is the module file with the extension py? Yes. Module is nothing but a file containing the functions. So and when we say import mylib, it is going to import. It's going to find, if I say import mylib, it's going to look for mylib.py in my path. Okay, and then import all the functions here. Question from Sakti, where is the recorded video of the last session? It would be available on the YouTube channel, as well as it will be available in your My Courses tomorrow. Okay, so what we learned was then that we created our own module quickly, and then we are using that. Okay, we are using that. It is saying that there is no method called compound interest. Why so? Maybe I'm making a typing mistake. MyLib does not have an attribute called this. Okay. Let me just rename it for time being. My underscore lib. Okay, I just saved it. My underscore lib. And I'm calling that with this. Yes, I think it was conflicting with something else. So yes. All right. So just to rename the module, all I had to do was rename the file, and that's it. A question from Kamal: can I quickly see the source code of a particular function in a file? I'm not sure. I'm not sure, but you can quickly see the whole file and use that. Okay. And I'm sure that it does. Does it provide us some editor here? Edit my underscore lib.py or cat? Yes, you can use cat and then see. Yes, Noor, I'm able to see your questions. Oh, I see. Okay, there is something called Q&A window as well. I was not looking at the questions window, so thank you for reminding. Okay, so a question from Noor is, so import star will only import functions. That's right. And what else could be part of module? Functions, classes, and other data structures. That's right. Very good point. So import star will import only the functions. It will import everything what's there in the file. Okay. Now, what else could be part of the module, like functions, classes, etc.? Yes. So is there a way to secure the internals of the modules, like not anyone to see what's inside? In case of interpreted languages, that's kind of not possible. So the way what people do is they try to obfuscate it, but in case of Python, that's even not possible. Okay. All right. So Noor, we can use the chat window itself. That should be good enough. All right. So what we learned was something interesting. We learned that we could create our modules quickly. We could import a module like this. We could say from my underscore lib, this was the name of the module, we could only import these two functions. Or we could say import asterisk. Now, when we do that, these functions are going to be made available as if they are local functions, right? So we could call this interest function like this, okay, like this. So this function, what we have imported from this module, becomes part of the uh, current context. So this way we are able to use any functions easily without having to say my underscore lib dot something. Okay, so these are another ways of importing methods in Python. Okay, importing. First one was import mylib. In that case, mylib got imported, and we could call all the methods of mylib or all the classes of mylib we could use. And in the same way, in the similar way, we could also say from the module and import the functions or the classes, and we could use those. Or we could simply say import asterisk. Okay, so to take a look at the name of a module, we could say mylib dot underscore underscore name. These are the internal methods, and it would show you the name of a module. Okay. So imagine that you would like to write a method in this class which will run only if you are explicitly calling explicitly running this this class, right? In that case, what you'll do is you'll say if name equals main. So a lot of methods will, let's say you want to run a particular function only when people are directly calling this as a Python program, because it's a valid Python program and people could call this Python program directly as well, right? And in that, if you want to restrict it, then you can put a condition like this, saying if the name of the module is main, that means that means um, that means it will be run only if you are calling this, you are running this program directly. You are running it like Python my underscore lib.py. This will not run. This will not run. This will not run if we are importing this module. Okay. So this print. This will. Okay. I think. Yeah. The font got changed. Yeah. This will not run when we are importing this module. Okay, if we are importing this module, say import mylib, that the function did not run. But if we did not put this kind of a condition, right? If we did not put this kind of condition, then this function would run. Okay. Okay. So let me just change the name, because these modules once get loaded, then they, okay, once it gets loaded, has to be unloaded. Okay, so let me just remove this part, or maybe just create another one, and I'm saying import my underscore lib underscore, and you can see that main has printed. Okay, so whatever you do in this will get executed. If you want to avoid that happening, you put this. Okay, so now it is imported and the main method is not called. Okay, so but if we say %run and say mylib.py, it should run the main method. The name main is not defined. This is correct only, right? Or I'll just print. For time being, I'll just print what it means by this method. This is correct only. Okay, so what I'm trying to do is I'm trying to call this as, okay, so I think, all right, it's basically a string. The name is a string, so I have to just put it as a string. So that was a mistake. All right, now what I'm trying to show you is that if you want to want to execute a particular piece of code only when you are running it as program, then you put it inside this kind of condition, right? Those who are coming from Java, they would be very used to writing public static void main. But here, because the creating module is extremely simple. Creating module is extremely simple. You just create a file and put the functions in it and then start using it, right? So you can see that I will put something more inside the main method. Okay, let me again load it. So you can see that while I say run, only then it creates it launches this method, but not here. Okay, if there was a method saying here print inside inside mylib, then this method will be called every time. Let me just change the name again, or my general lib. I'm changing the name because otherwise I'll have to restart my Python kernel. And yes, because the name gets cached. And okay, so you can see that here when we import this, so I'm trying to show you is this function is getting called even when we are importing things. This function will get called even when we are importing things. Okay, and once we import it, then this function will not be imported again. Okay, that's why it won't be printed again. And when we run the program, the main method, this one will be executed. All right, so this condition basically stops a certain piece of code being called while being imported as the module. A question from Pavan: can module have class detail just like functions? Can module have class? Yes, you can have. Okay, thank you, Gaurav. A question from Binta: what can we do with name equals main method in FilePy? I think you got the idea now. So the idea is to restrict certain piece of code from being executed while it was being called as the module. Okay, so that was a quick idea about modules. This is important to just give you a hang of what's where. All right, it's extremely simple. And also one thing to note is that there's something called system.path, and system.path is something which Python goes through in order to locate your module. Okay, so and the way you add system.path is nothing but an array of things, and you have to import sys and say system.path. Okay, so here you can see that these are the places when we say import something, when we say import OS or something, it's going to look for those things at these locations. Okay, including my home directory .ipython. Okay, it's going to look for these modules at these locations. All right, so we can also add our own place, our own folder into this list. Okay, let's say you have a good team and you are maintaining a project. So what you do is the common functionality, common things, common legacy code, we can put at a single folder and everybody can import from there. So that way we can share our piece of code, our libraries or modules. Okay. So when we say pip install, it downloads and copies the modules in the site packages and makes it available there. Okay, so that's about it. So we can uh, copy this mylib.py in the syspath, and for example, I have put testmod.py in my tmp folder. I'll show you. If I go to my root folder, okay, this is my home directory in CloudxLab. At here, I have created a folder called TMP. Inside TMP, I have created a file called testmod. Okay, testmod. Okay. Now, if I try to import testmod, it's going to give error saying testmod is not found. Why? Because why? It's not going to look for this in my TMP folder. So to make it do that, what I do is I added my folder in which my stuff is there into the sys.path array. Okay, and once we have specified this directory, we have added sys.path, our directory, to the list. You can see that it has appeared here. And in fact, since I've executed twice, it has appeared twice. Now, when I say import test mode now, it's going to find in this. It'll try from here and till here. Okay, so you can see that it has found my module. All right. So this way we are able to create our own module. Question from Noor, from where it installed. What's the use case when we want to run the module instead of importing it? Okay. All right. Two questions. From where does it install? There are pip repositories from which it downloads. Those are provided by the pip command, and you can pip internally goes to those repositories and downloads it based on various dependency graph. Now, what's the use case when we have to run module instead of importing it? Generally, the entry point of your program, when we run something, let's say, whenever we are running, whenever we are running things from the command line, uh, then we have to use the main method. Okay, so if you want to provide an entry point, let's say you build a program and you are giving it to somebody, and they are going to run it from the console, and in those cases the main method comes handy. All right, I hope that makes sense to you. Now, packages are another thing in Python. Packages are a way of constructing Python's module namespace. For example, the module name a.b designates a submodule b in a package name A. Say you have a huge project sound. The top level, say, say, say you have a huge project, and let's take a look at this project. This project is called sound, right? Sound has got folders like formats, effects, and so on. So to create the namespace in case of Python, all you need to do is create this package, create this folder structure. This folder structure looks like this: formats, effects, filters, and so on. So, and to mark anything as a package, all you need to do is create this empty file. Create this empty file in that folder with this name exactly. There's no need of putting any logic. If you want to put any code that you want to run when the package is imported, then you can put that in it. Okay, but there's no need of anything inside this file. You can just have an empty file, and that's pretty much. So take a look at how to create the packages. Okay, so you can basically create a package of your own and use that. And these are the modules. Each of these are the modules. Okay, this is a sub package. This is a big package. So package can have other packages within it. Okay, and the package must have this file even if it's empty. Okay, once we are done with this kind of folder structure, we can then either say import sound.effects.echo, sound.effects.echo. That's the module, the last one. Or we could also just say import sound, and then we could call sound.effects.echo.echo filter. Okay. So if we are importing things like this, saying import sound.effects.echo, we're going to use this whole name along with that. A easier way would have been saying from this particular package, import echo, okay? Or from a particular module, just import a function. So these are other ways of importing function. So it is up to you whether you want to just import functions or classes, or you want to import a package, or you, if you just want to import a package, then also you can do that, or you could import the whole namespace. Okay, so this is how the packages work. All right. One more thing I wanted to explain to you is using percentage time it function the inside the inside Jupyter. It gives you how much time it would take. So time it is a utility that you can use in normal programs as well to see the time taken by any program. Let's say we want to see how much time is being taken by this compound interest. Okay, so we could say percent time it, and that's it. So you can see that it is trying to compute the interest, and for whatever reason it's taking strangely a lot of time. Okay, okay, so time it is taking a bit of time. Let me just try to trust this notebook. Maybe it will make it easier. Okay, so while calling any function, we could use the timeit utility provided by Jupyter in order to just test if something is working fine or not. So here, this is what we were showing. So interest method we are calling by the way of timeit. Okay, it'll show you, it'll run the function via profiler and would display the detail, display the time taken by the function. So it says that interest computation took around 169 nanoseconds. Okay. All right. That's pretty much with respect to the Python in general. Now let's continue with the NumPy. That's right, Kamal. If I import a function from a package that has the name overlapping from another function, then the latest definition would apply. That's correct. Yes, Binta, you have a question for me? Just go ahead. Okay. Actually, you had raised the hand, so I thought. All right, wonderful. So after the break, we are going to talk about. Let me minimize some of the windows. Okay. Now, after the break, we are going to study the uh, other parts of the course, which is machine learning foundation tools, NumPy. Okay, so all right, I hope I've not missed out on anything. All right, great. Today we are doing good because thanks to probably Zoom that I'm able to see your questions quickly, and you're able to, there's no gap between what I say and what you hear. Okay, so all right, so we are going to discuss the NumPy after the break. Okay, a question from Vinta is that, will there be another session on Saturday or December 2 in IST or December 1 in PST? The answer is no. Let's see if we can cover something. If something is left today, we can cover that. We can have an extra session. We purposefully kept a gap between the December 3 session and the Python course so that in case there are many questions, we could we could cover those in the gap. Okay. So let's see if we can finish it if today, and because I do not want to rush into anything. If your questions are not answered, there is no point of running these sessions. Therefore, instead of me trying to just run through everything quickly and you not able to understand, I would better answer your questions. Even if I have to run extra sessions, I'm completely okay with that. All right. So that's the sole idea. So that's why I've kept um, that's why I've kept a gap between the sessions. All right. So let's see if we can finish it. It's great. A question from Kamal: don't we use interfaces that much in Python? We do not use that much. Okay. And you will, once you think about the strongly typed language and loosely typed languages, you will get to know that interfaces are not much required. All right. Wonderful. So let's take a break for 10 minutes. Okay. 10 minutes. Keep asking a question and okay. Okay, so let's take a break for 10 minutes and we'll be back in some time. All right, should we start? Great, wonderful. All right, so what is NumPy? NumPy stands for Numeric Python or Numerical Python, and it's open source and it's a module for Python. It provides fast mathematical functions, and this is the ecosystem that completes machine learning, completes the machine learning landscape. So in using Python, so we learned Python already. We are comfortable with basic syntax of Python. Then we have pandas, NumPy, Matplot, TensorFlow, and Scikit-learn. These parts are small libraries, while these are a little bigger libraries. Okay. Okay. So basically, the most of these are just the modules and that we can use in order to achieve things. Just that these modules are larger and they have their nitty-gritties, and therefore we are learning individually these modules. Okay, if you are trying to do a web application, you're trying to build a web application like the way we have built CloudxLab or something else, you could use Django. Django is another module for in Python. So Python has all kinds of modules, and we're going to go over the modules that are needed for data science, machine learning or analytics. Okay. NumPy provides you a big array. NumPy provides you a big array, which is extremely fast. And Pandas provides you a big table structure, which you can query. And Matplot provides you the ability to plot graphs. Scikit-learn provides you the machine learning algorithms, while TensorFlow provides you a way to do graph computation. Question from Kamal: what does the overlap of? What does overlap signify here? The overlap signifies that Matplot understands NumPy very well. Similarly, Pandas and NumPy are also overlapping, although in the diagram they are not. Scikit-learn heavily depend on NumPy, as well as pandas, and TensorFlow also depend on NumPy. So most of these systems, whether scikit-learn, TensorFlow, all of these, they kind of assume that you have NumPy as well as you have matplot. So while solving the problems, we will be using a combination of these. So the second session, just after the introduction of machine learning, what we are going to do is we are going to go over the entire case study of the machine learning first, and there you will notice that we use all of these components except for TensorFlow. We will use all of these components in a single shot. All right. So now let's face one important truth. Python programs are not very great when it comes to efficiency. The performance is not very great. But Python programs are sophisticated and easier to write, and therefore most of these libraries are available in Python, though these libraries are written in C. Most of these libraries are either written in C or C++. All right, let me just show you a quick example and right. So let's try to understand the motivation behind the NumPy. I know that this is going to be something that we are doing before learning things. Okay, so here I'm just going to go ahead with with something something that is not yet learned. So be with me. Trust me, doing things before learning them is generally better for learning. You will not be able to get the entire grasp, but you will get the general picture. Okay, so what I'm going to show you is the motivation behind NumPy. NumPy is nothing but a big list. Just like in Python, you have list. NumPy provides you this big list. The only advantage of NumPy is that this list is extremely fast as opposed to the usual Python. So NumPy provides you this big array or list on which you can operate, and it's extremely fast. Okay, let me show you how much efficient it is. Imagine that you had to do a multiplication of array, right? It's pretty simple. We could say I from range this to that, and we are writing our own operations. Python These are normal Python lists, A, B, and C, a normal Python list. Okay. And let's say we create these two functions. One is using this, other is the internal one. Okay. And now what we're going to do is we are going to initialize X and Y. Okay. And then call these functions. Okay. So you can see that I've just executed this time it. And when we use the multiply loop, it's taking close to half second. Okay, but if I use the NumPy way of multiplying using the internal function, the method is extremely fast. So you can see that here it took around 28 milliseconds. If we use the internal function of NumPy, and here it took 465 millisecond. Okay, although both of these are NumPy only, most of the parts are NumPy, but if you do it further using the normal Python libraries, you will find the difference is really huge. Okay, so the point I was trying to show you is that using timeit, we could measure the performance of various things, and the NumPy's internal operators provided to you, NumPy's internal functions provided to you are far more efficient than the usual Python list. And therefore, for mathematical operations, we use NumPy instead of the default list. Okay. Okay, so you can see that the first function where we wrote the logic of multiplying things, it took around half a second, right? And when we use the internal function, the this one using multiply vector, then it took 28 milliseconds. Okay, is that what you wanted to see, Binta? Do I need to zoom it? So there are two functions. One is using loops, and other is using this internal operators provided by NumPy, and this is what it is. So the point I'm trying to make is that I'm just trying to set the the motivation right. We use NumPy for performance, and NumPy, other than performance, the other thing what we use NumPy for is this wonderful set of library provided by NumPy with which you can do a lot more on matrices and lists. All right. Okay. All right. Actually, I'm not showing the resulting output. It's basically multiplying two matrices. Don't worry if you have no clue about multiplying matrix. Don't worry. You just think of this as we are doing something complex, writing our own loops, as opposed to doing something using NumPy's internal operators. Okay. So all I did was I wrote time8 and called it here and said shift enter. And I'm not printing the result yet. Okay. At means here, at is an internal operator provided by NumPy for multiplying two matrices. Whatever we are doing here, the same thing is provided as an operator on by NumPy. We could the libraries could create their own operators on their objects. Okay, so-called operator overloading in the traditional languages. Okay, so this is what it is. So at is faster because it is implemented by NumPy. So NumPy is far more efficient. It is faster for two reasons. One, NumPy is written in C. The other reason why it's faster is because of various optimizations they have done on they have done um, on matrix multiplication algorithm. Okay. All right. So when we learn the machine learning, you will find that 90% of the algorithms are about matrix multiplication. Matrix multiplication, we will learn matrix multiplication soon. If not today, we will do it over the next week, and we will get a clear picture of what it means by set of equations, how to solve them, how to use machine learning techniques to solve those set of equations, and we will learn that part as part of linear algebra. Although mathematics is kind of good to know, but not too detailed mathematics is generally required because most of the core algorithms are available for everyone. So, so mathematics is good to know, but that does not mean that that should stop you from learning machine learning. Because earlier when people were learning algorithms, people thought that you need to know a lot of maths, right? That's why if you take a look at the book called DE Nuth, half of the book is mathematics. Half of the book of DE Nuth, Nuth is kind of the biggest piece of work. And so earlier when people were learning algorithms or normal programming, people thought that one must learn the mathematics first. And same is the scenario with machine learning, that it's a new field, and since it's a new field, and therefore we should all learn the maths first. But that's not true. That's not true. once you get the hang of data, once you get the hang of how to use various algorithms, you don't need to know exact semantics of algorithm. Okay, and you should be able to utilize existing algorithms. Okay, but if you are creating your own algorithm, machine learning algorithm, then you might need to know maths. All right, but we are going to go over linear algebra quickly, how much ever is required. A question from a question from Noor is, so all these libraries are here to support machine learning, but do we have to know the theory and philosophy about machine learning? Of course, of course. We are going to do that on December 3 IST and December 2 PST. Okay, same time. All right, great, great. So I just wanted to show you this part. All right. And also those who are really impatient, they can try plotting the graph using plot. Okay, where did my plot go? Okay, so here let's say we are saying plot.scatter, and all right, so what we can do is from let me try writing this piece of code. Okay, plt dot plot 1 2 3 4. It should work, I think. You can see that I just drew a line. Good. So we are able to quickly plot things using matplot. You could give it a shot. It's really, really smooth and easy. Okay, so you could give the values, let's say here, and let me put it the other way: 4, 3, 2, and 1. Okay, let's see how it looks. So you can see 4, 3. Oh, this is supposed to be 2. 4, 3, 2, and 1. So we can plot the graph really quickly using this library. Okay, so we are using the pyplot, and that's pretty much. All right, so using the matplot library, we are able to plot all kinds of graphs, and we will use that more and more. Like here, we are trying to plot this complex graph with all kinds of parameters, and let me just show you plt.show. Okay, so we can plot many graphs as well. So we could actually plot multiple graphs together, and so experiment with this, and this should be good. Okay, what happened? It did not go up. I think there is a way to do a multiplot. All right, we'll go into these details as and when required. But matplotlib is what we're going to use to plot the graph, because when we look at the graph, it kind of makes more sense of the data to us. All right, so we talked about two things. NumPy is an external library which is really efficient, and we're going to learn that part. Second thing we talked about is the matplot, which is really fast library. All right, so we're going to go through the theory part a little faster and practical a little more. So NumPy provides you the array-oriented computing. It efficiently implemented multi-dimensional arrays, okay, and it's designed for scientific computation. It's library of high-level mathematical functions. Okay, I think okay. All right, never mind. I'll just show it from here. This is far better. All right, so okay, NumPy's main object is homogeneous multidimensional array. What does it mean? It means it's you can only have one kind of data in NumPy, and you unlike Python's list, which are really flexible and you could put any kind of things in it. In case of NumPy, you can only have single data type. And multidimensional array means you can have array within an array. So it is a table of elements, usually numbers, and all are of the same data type, indexed by a tuple of positive integers. And in NumPy, dimensions are called accesses, and the numbers are called the number of accesses are called rank. Okay, so this will make more sense to you. Imagine that you have this kind of array of arrays or list of lists. You can see that there is a square bracket here, there's a square bracket here. This is a list, this is a list, this is a list, and this is big list. Okay, so it is a list of lists. This is array of arrays. And in case of NumPy, we call that the first dimension or the axis and the second dimension. So first dimension is this one. How many elements does it have? 4, right? That means the length of this one is 4. And how many elements does this one have? 3, right? 1. How many rows does it have? 1, 2, and 3, right? There are 3 rows, 4 columns, correct? There are 3 rows and 4 columns. That means it's a 3 by 4 array. It's a 3 by 4 what do you call table. So basically it's a 3 by 4 matrix. It's also called matrix. The tabular form is also called matrix. It's a 3 by 4 matrix, and since there are total number of axes are 2, one x-axis, other is y-axis, therefore its rank is 2. Okay, had there been some z-axis also, imagine that there were 3 square brackets here, then it would be a 3-dimensional array. Okay, the rank will be 3. Now it's really easy to create NumPy arrays. I'm going to show you in Jupyter. Okay, and where is that? In the same folder that we have been working with, in the same folder you will find that there is a notebook called NumPy. Not this one, not this one. This one is, I think, empty. Let me just check what is there in this. Yeah, this one is kind of empty. So, all right. So let me just delete it before. Okay, so let me also commit these changes. Okay, so yes. All right, so I've deleted that extra one, and now there is only this Python NumPy. Okay, in this almost everything is there. To get started with NumPy is pretty simple. You can just say import NumPy, or you could say NumPy as NP so that it becomes easier. Yes, I have done that. I pushed the latest code with that. Thanks. Okay, now that's it. Now we are able to import NumPy. All right. Now to create a NumPy array, what we have to say is NumPy, which is NP here. We are saying NP. If we say this, then we'll have to write everywhere NumPy. Okay, like this. So we can use the as keyword as part of the module, and we could import that. So you can see the type of A. A is basically ND array, meaning n-dimensional array is the data type of this. So array method of numpy module creates this numpy module creates this array, right? We can take a look at what it looks like, and you can see that it is pretty simple. Okay, now similarly we can define another variable. Also, if you want to just fill up, if you want to fill up a particular we want to create a array filled with zeros, and we want 3 to 4 dimension, meaning 3 by 4 dimension. 3 is the number of rows and 4 is the number of columns. Then we could say np dot zeros, and please notice this is a tuple. This is a tuple here. Okay, and let me also show you how does it look. So you can see that it has created an array X with 4 columns and 3 rows. So what's the rank of this one? The rank of this one is 2, because there are 2 dimensions, right? In one dimension there are 3 elements, and each element is 4 length. So you can see that this is the shape of the array. Okay, now we could fill NP once, meaning if you want to create a fresh array with only ones, then we could use this. Okay, and those who are wondering what happens in case we create an array with say 3 dimensions. Okay, let's say I define 2 by 3 by 4. Now you can see that this is 1, this is 2, right? So you can see that this is a 3-dimension array. And I think x.rank is there. No, x.rank is not there. X.shape is there. Okay. So basically, using zeros method, you could create a fresh new array filled with zeros. With NP1, you could create a fresh new array with all filled with 1. Also, by default, the data type of this one is int 16. Okay. And we could change the data type, or we could actually not change, we could we could explicitly define the data type of our choice. Okay, so we could change this to say float 16, float 64, and that way it'll create an array with the different data type. Okay, so you can see that. All right, so what we are trying to do, we are trying to create an array filled with zeros or ones. Both filling with zeros and ones is very common. Therefore, they have provided a function which does that for us. But there is another method called full. What does full do? It creates an array filled with a particular value. Okay, filled with a particular value. So you can see that it has created an array filled with 0.11. Okay, filled with 0.11. Similarly, we could also create our array filled with, say, I think there is something called np.py. It's not there. Okay. So if you want to create a 3 by 4 matrix, 3 rows and 4 columns filled with pi, then we could do this. Okay. So, all right. Now, just like we had range in Python, you remember the for loop where we used a function called range to generate all the numbers starting at some point till the end, right? We could also do same in case of the NumPy. Using NumPy arange, what it does is it starts at a point, the first argument, till this value, but not including this value, and with a gap of third argument. Okay, so if you do not provide this, it is going to create an array with 1 as the difference, but up to 30, but not including 30. Okay, so if we say 6 here is going to go up to 28, but not beyond it. Got it? So a range generates the numbers starting at certain point till the second argument and with a gap of third argument. Okay, so start at 10 with a gap of 6, meaning 10, 6, 16, 16 plus 6 is 22, 22 plus 6 is 22, 28, and so on. So this range is basically generated by those three values. If we say 2 here, it will generate all the even numbers up to 30, but not including 30. Okay. All right. So the same is true with decimal number. Let's say we want to generate all the numbers starting from 0 up to 20, and we say at a gap of 0.1. You can see that so many numbers have been generated. 0, 0.1, 0.2, 0.3, 0.4. Okay. All right. So I hope that makes sense to you. So we can generate a sequence of numbers using this method called a range. Okay. Now, a question to all of you is that if you are given this list, you see this one, what is the shape of it? What is the dimension? A question from Manoj is array and matrix are same? Yes. Array is basically array of elements and matrix is array of arrays. Okay. Matrix is more like a table of numbers. Okay. When I say shape, shape means the dimensions. What is the use of arrays and what can we do with it? A lot of mathematical operations can be done with arrays, and that's why arrays are predominantly used in machine learning. Okay. So the dimension, how many, this array has how many elements? 1 and 2, right? That means 2 by, and this one, this element has how much? 1 and 2, right? Sorry, 1, 2, 3, 4. This array has 4 elements, right? So this means it is 2 by 4, and this one has only one value. That means it is 2 by 4 by 1, right? Now, if you are given a normal list of lists in Python, we could create array out of it, saying np.array and pass x, okay? And then let's say, okay, so uh, we've just created XX with those details. So you can see that this is array of arrays. Okay, so the shape of this one is how much? This shape of this one is 2 by 4 by 1. Is it clear? How many elements does this array has? 1 and 2, correct? And the second one has how many? 1, 2, 3, 4, right? And how many does this one have? 1. So this is 2 by 4 by 1, correct? Everybody comfortable with this? Kamal? A question from Kamal is, what if it was not homogeneous? NumPy is going to throw an error on that. Try that. Because the objective is to make sure that all of the data types are same. And first it tries to upcast all the elements. If let's say you put one decimal and all of them are numbers, first it tries to upcast all of them to decimals. Okay. All right. And otherwise it throws an error or does something about it. Great. So a range creates this wonderful creates the sequence of numbers starting with given a starting point, an end point, and optionally the gap. Okay, and using shape attribute of the NumPy array, we can always check the the dimensions of matrix. All right, now let's say we would like to generate 50 numbers evenly spread between two numbers, right? Let's say we want to generate evenly spread out numbers, right? So here we are doing that. Let me take an easier example first. Okay, here is an easier example. Let's say between 1 to 100, we would like to generate the numbers with a gap of 10. Okay, so here, as opposed to the previous methods, here the 100 is included, and these are the numbers with a gap of 10. And what happens in case of 9? Okay, in case of 9, we have these. What about 8? No. And what about 11? Yes. So if we say 11, so what it did was it generated total 11 numbers, including 0 and 100. All right. So if we say between 1 and, so it basically generates the numbers evenly distributed between the two extremes. Okay. So between 0 and 100, if we say generate, say, or between 0 to 10, or say 1 to 10, 1 to 10, we want to generate 25 numbers. So it has generated these numbers. Okay. So using linear space, it would create these numbers evenly spread out. So what all we learned? We learned about the shape, we learned about the linear space, we learned about a range, and we learned that we can always create array using array function. We can convert any list of lists or any list of Python into NumPy array. Or using ones and full and using zeros, we could create these matrix full of that number, right? Those are the things that we learned. And of course, we can create a matrix filled with random numbers.
This again is quite important when we learn about further about matrix multiplication. We would be able to generate a matrix full of numbers. Here, full of random numbers. Full of random numbers means the number between 0 to 1. That is the random number. Okay, so here we are generating a matrix of two rows, right? Two rows, each having three columns, and all of the numbers are between 0 to 1. All of these numbers are between 0 to 1. Okay, so this is how these are some very cool methods that we could use. All right. So we learned about all of this, and we can check the data size, and we can also use a method called item size in order to find the number of items. So say, for example, we are generating this C. C has how many elements? 1, 2, 3, 4. And the data type of C is 64-bit integer, and the size it's taking is basically 8. Okay. So it's an 8 byte. Each element is going to take 8 byte of space. That's what it means, right? Why 8 byte? Because 64 is essentially 8 into 8, which is 8 byte. 1 byte is 8 bits. Now, we can change the shape of one list into another. Imagine that we have created a simple list of numbers from 0 to 5, and we would like to convert it into 2 rows and 3 columns. So it's going to go up to 3 elements, put a break, and then create new record. Okay, so these elements went into the first row, and these ones went into the second. This is called reshaping an array. Okay, this is called reshaping an array. All right, so these are very handy methods that once we know that they exist, it'll be very useful to know. Okay, also for the impatient, you can generally take a look at dir and np, and you'll see all kinds of methods there. Okay, you have abs, absolute, add, and so on. There are huge list of arrays. You have bitwise operators. You have all kinds of operators, methods available to you. Okay. Now, so we'll focus more on the concepts. Rest you can generally figure out, or we will learn whenever required. Okay. So here we are creating an array out of the Python list. Okay. And we can access an individual element just like usually we did. 0, 1, 2, 3. That means 19, right? That's what it is. It is in NumPy also, just like Python list, the arrays are accessed by using the index, and the index starts from 0. That means if I say 0 here, it's going to print 1. It's going to print 1. And if I say 1 here, it's going to print 5, right? 0, 1, 2, 3, 4, 5, like that. Okay, so if you want to access a particular range, this is something unique about Python. And if you want to say, give me everything starting from 2, 0, 1, 2, up to 5. So 4, 5, right? 0, 1, 2, 3, 4, 5. Up to 5 meaning only till here. Just one element less than 5. Okay, so we get 3 up to 313. Okay, is it clear? I hope if the arrays were clear earlier. Now, right? The other cool thing is that we could also say, give me all the numbers starting at certain point, okay, till the end with a gap of 2. Okay, so starting at 2, 0, 1, 2, okay, with a gap of 2, meaning 1 and 2, that is 3 and 13, and then 3 again. Okay, so we can also quickly pick and choose the numbers by jumping the range. Okay, we are basically hopping between the numbers. Here, if we say start at 2 and with a gap of 3, that means start at 2 with a gap of 3 means next number is going to be 7, right? And if we say -1, that means we will start from the back and go towards this side. Okay, so we'll start with 3, 13, and 3 and 1. That's what it means. Sorry, we'll start from here because the gap is only 1. So we'll start from 3, 7, 13, 19, 3, 5, 1. If we put 2, then it'll start jumping and it'll become 3, 13, 3, and 1, right? Is it clear to everyone? All right. So we could hop between numbers and reverse this array very easily. And this is a cool technique to reverse a array. Okay. Also, a very interesting part is that we could we could update a whole range of values in a single shot. So we could say a 1 to 3 and equals -1. That means this will become -1, this will become -1, and this will become -1. Sorry, this and this 0, 0, 1, 2, yes, less than 3, correct? So a 1 to 3 is 5 and 3, right? And if I say equals -1, these two numbers are going to be updated with -1. Okay. So using this technique, you could update a range of values in a single shot. Okay. We could also say that update alternative numbers, alternative numbers using this. So we could say jump by 2 numbers. Okay. Okay. Jump by 2 numbers and update with -1. So you can see that starting from here, it got updated with -1, it got updated with -1, it got updated with -1, and it got updated with -1. Okay, and let's say what we want to say is starting from 1, okay, now update the rest with 0 with this. So you can see that these numbers now have been updated by 0. So this way you can always manipulate the array. Okay. All right. So we can update all values in a single shot. A question from Tanmoy is, why did 19 not change? Here 1 to 3 means 0, 0, 1, 2, not 3. The last range is never included. Correct? If you want to test, you can do that. Print A. See that? All right. So this way we could always update values and change a bunch of values in a single shot. All right. Then comes the, also please note that even if we assign this to another variable, this range, and then update that slice, the actual value will still get updated. For example, here we are creating a NumPy array. Okay, we are creating NumPy array and we are selecting a portion of it. Okay, so this slice is going to point to values from here to here, 0, 1, 2, 3, and up to here. No, I'm sorry. It starts with 1 till 4. So this is 1, 2, 3, 4, up to here, right? So we created a slice that points to this portion of the array, and we are saying update the first element of this slice. What is the first element of this slice? This is the first element, because a slice is going to look like this. This is going to look like this, right? So the first element of this one is going to be this, right? And hence, this, if we assign the first element of this will become 1000, and effectively this will also get updated. So that's why we are printing a, not a slice. So you can see that this value is updated with 1000. Yes. Thank you, Tanmay. Yes, that's what is happening. It's basically kind of pointer. So we are dealing with NumPy array. Okay. If you want to change some value and do not want to impact the parent one, in that case, you could use a method called copy. You could copy a portion of array and then keep changing it without having to update it. So another slice here has the older value, newer value, while the actual one remained unchanged. Okay, so this one is unchanged while this one got updated, right? Is it clear to everyone what it means? So we are basically uh, modifying the same array if we are operating on the portion of it, okay? The reason why it is done is so that by default, the performance remains intact. If we, every time we do something, if there is a new matrix being created, the overall performance and the memory consumption will be too high. Okay. Now let's just create this X filled with 5 rows, each having 8 columns with random numbers. Okay. So if we say X1 is basically a array in itself. You can see that it's an array in itself. And if you want to access one, uh, the if you want to access say this particular value, we could say X11. Okay, we could say X11. X11 means 0, 1. This is wrong actually. Why it is happening that way? 0 is this, right? And no, this is an older value. Yeah, now it's correct. So we are saying 0 and 1. This is x1, right? This is x1. Now here when we say x1, we get this value. Either we could say x11 or we could say x1 like this, okay, or this. Both are same thing. You could access an element using either this or this. Okay, this one saves some more keystrokes. Instead of 2, you are just typing 1. Okay. Also, if you want to cut out a portion of this matrix, if we want to cut out a portion of this matrix, what does it mean by cut out? Let's say, let me just print it again. It doesn't. Let me make it a little smaller. Maybe this time it'll fit. No. So let me just make it 4 by 5. I hope that fits. Okay, this is good. So imagine that we had this matrix and we would like to cut out a portion of it, right? we want to cut out a portion of it. Let's say, let me just show you properly. Imagine that we have this matrix, and what we would like to do is we would like to access, say, a portion of this, right? We would like to just access this portion. Then in that case, we could use a mechanism like this one. We could use a mechanism like this one. We could say, give me rows ranging from this to this and this to this. Okay, so here what we are saying is, we are saying, give me these two rows 0 to 2. Okay, and out of each column, give me these ones. So what we are getting is, we are getting from here to here. Okay, let's check it out. So you can see that we got this, and we got this and this, right? So that's how we can cut a window from the actual matrix. Okay, so that's how we can actually slice a whole array. Okay, and here we are generating really huge array 5 by 5 by 5. How many elements? Quickly, who will tell me how many elements will be there in this X? How many random numbers? 125. That's right. So it's going to have 125 elements. Okay, so it's kind of a cube, or it's kind of cube, meaning every dimension is equal, and there are so many numbers. So if we just want to take first two records from all, let's say this is first, so this from here to here is first, and then and so on. So you can figure it out, and we can do that in that case also. So we can take a small cube from a big cube easily. Okay, and of course you can select different dimensions here. All right, so we can cut out a piece of an array, piece of a matrix easily. Okay, also we can use the reshape function to quickly create a array. So here we are creating array of a matrix of 3 by 4, using reshape. So you can see that from 0 to 12, not including 12, we've converted that into a 3 by 4 matrix. 3 are the rows and the 4 other columns. All right, now what actually I want to show you is, let's say we would like to pick and choose certain rows. Let's say we would like to choose only first and second. So we create another array, saying, putting tick marks here, that we want the first one, we don't want the second one, and we want the third one, by the way of saying true, false, true. That means the first row, which is this, will be kept, the second row will not be kept, and third row will be kept. Let me show you. So row is basically an array of booleans, right? The data type of this row on is basically boolean, right? It's basically it is essentially another array. Now, and this A, we know it already, that this is our list. So we are saying A rows on, and this is showing us these records, right? It's picking up this one, ignoring this one, and keeping this one. Okay. In the same way, we could also say that give me elements on the other side. Let me just see if it works. So I'm saying false, true, and false. All I'll do is I'll say np dot array. Okay, so it says that you cannot do that. Let me try with this other syntax. No, I can't do that. Why? 2 plus 2 is 4, and okay, I think I just need to put this inside a square bracket. Now you can see that. So it says true, false, true, false. Okay, what does it mean? Oh, looks like it doesn't work it this way. So this is okay. This I totally agree on. But if I just want to pick 2 from each side, probably I will have to say something like this. So true, false, true, false. No, it is not working that way. Okay, so we'll take a look at this again. So the point that we were trying to reach to is to select the rows based on a particular vector. We'll see the column selection soon. Let me undo everything that I was doing here. Okay, so yeah, this is okay. Now, this way we can do the row selection. Column selection, I don't think this is done this way. We'll try some more things. Also, we can do the additions on the matrix. Okay, we could do the additions like this. We are saying let's say we have A, which is from 20, 30, 40, 50. And then we have 4, which is 0, 1, 2, 3. That's how it will get generated. And we can just take a look at how does B look like. A looks like this, B looks like this, and C looks like this. Okay, so this is how it is. So this is an array, this is another array, and when we are adding, it's basically adding 20 to 1, 20 to 0, 30 to 1, 40 to 2, and 50 to 3. So this way we can add two arrays, and we can also subtract 2 arrays. Okay, we can also multiply two arrays. Okay, if we say A into B, it's basically element-wise multiplication. 1 will get multiplied to 2, 1 will get multiplied to 0, 0 will get multiplied to 3, 1 will get multiplied to 4. And that's how we get the results. So you can see that it has multiplied, it has done the multiplication like this. Okay, just to give you an example, I have also done the manual multiplication. All right, so we could subtract, multiply the 2 arrays. We could slice it. We could fill it with zeros or ones. Okay. Now, there's something called a dot product. We could multiply. So we could multiply 2 matrices or 2 arrays using something called a dot product. Okay. What does it mean, dot product? Dot product means let's say we have these. So we'll first multiply this with this, okay, and so on. All right, let me just see if I can demonstrate in a better example. Dot products are very important things. For now, let's just assume that dot products are really useful. We are going to go into details like where do we use dot product. between two matrices. Okay, a question from Kamal. What if the two arrays are not identical? We're going to cover that part as part of broadcast. Okay, and all right, so let me just show you what it means by okay, let me just show you what it means by a dot product. Okay, now I'm trying to pick these values. All right, so imagine that there are these two matrices, and what we want to do is we would like to multiply these using dot product. Okay, we call it dot product, and the way it happens is we take these two values. How do you? So we take this, multiply with this, okay, and sum up all the values. That means it'll become 1 plus 1 into 2, okay, plus 1 into 2 plus 1 into 3. So this value multiplied by 2, this value multiplied by 3, okay. So that becomes our new value. Okay, so I'm going to put it like this. Now, the second thing that we're going to do is same thing we're going to now multiply with this. Okay, so now we're going to multiply this with this. Okay, so and this. Okay, I'm just trying to see that if it doesn't select. Okay, never mind. So now this is going to be multiplied here, so it'll become 1 multiplied by 0 plus 1 multiplied by 4. Okay, let me put it a little bit more. Okay, so we basically are multiplying two arrays. Noor, don't worry. I'll take you through the course as we go ahead. Right now, we are just multiplying these two. Okay, and it's pretty simple. It's pretty simple. So you don't need to learn it from somewhere. Let me just explain again. So let's say we have 2 by 2 matrices. This one is 1. This is another. So row of first one multiplied by the column of the second one. So 1 into 2 plus 1 into 3, that becomes the first element. Now the same thing is going to happen here. 1 into 0, 1 into 4. Add it, and this is what it means by dot product. Now the same thing we are going to do with this and this, which is 2 into 0. Okay, 2 into 0. All right, 2 into 0 plus 1 into 3. Okay, so 1 into 3. All right, in the same way, what we're going to do is take this row, multiply with this column. So 0 into 0, 1 into 4. Okay, 0 into 0, 1 into 4. All right, that's what is the dot product. All right, it's pretty simple. Is it clear to everyone? Noor? So we are multiplying, we are doing the multiplication of these two arrays is pretty simple. Take the row of first one, multiply with the column of the second one, and so on. Okay, and that's what I'm trying to demonstrate here. And the good part is that we don't need to learn it. The numpy does the dot product for us. Okay, you can see that numpy has done the dot product exactly the way we had done. Okay, so all we need to do is np dot dot. All right, so looks like we have again run out of time, and never mind. So I think we have still one more day left, and we can plan one more session. So I think this is very much required. So we can just plan for like a 2-hour session on the coming Saturday. Okay, December 2 for us, and we can complete the pandas and the numpy in that session. Okay. Okay, we will aim for, we'll just go with our usual session. Thank you, Kamal. We'll just go with the three hours itself. And in case there are more questions, we can keep it maybe in the December 3rd, second half. Okay. All right, so good. I think 3 hours will be sufficient for covering the pandas and NumPy. Okay, so NumPy is good enough. You all must give it a try to this particular worksheet. Okay, you must give it a try to this particular worksheet. It is available in the same folder, the one that I shared with all of you. In the same folder, it is available. All right, don't get intimidated by the maths. It is pretty simple and you can easily handle it. Okay, so here is the link for the GitHub repository. A question from Noor: will we work on practical examples of machine learning use case? Yes, except for this initial part where we are trying to learn to walk, with the basic tools. Except for these, everything is going to be very much use case oriented. We will start with the use case and then we'll walk backwards. And that's the only way we're going to conduct rest of the course. Okay, so after December 3, we everything is going to be use case oriented. Okay, use case oriented. We will start with the use case and we will walk backwards and then utilize all the tools and techniques that we are learning in order to solve a problem. Okay, so those who are planning to go with the full course, they can go to the main site, CloudxLab. Okay, and you know, go to the machine learning specialization and you can enroll for the course. If this in this course, they're basically Python for machine learning, which is free, and machine learning and deep learning. If you are only interested in machine learning, not deep learning, you can enroll for this one. Otherwise, you can also enroll for deep learning. But I would strongly recommend that take up the entire machine learning specialization. This way, we are going to work together in order to solve one problem per chapter and learn the entire machine learning end to end. This is probably the most hands-on course, and it's a pretty big course. And 1/3 we have already finished, and 2/3 is only left. Okay. 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 Yes, Jupyter. All the entire thing is available right now. Let me just push the repository again if I have made some changes. Okay, I have pushed the repository again, and it is available publicly on the GitHub repository is available publicly to all. Please feel free to clone it And as Noor is suggesting that you could use GitHub Desktop. Okay, so all right. So I would suggest that come over and join the specialization, and we're going to learn quite the machine learning in quite details. Okay, so we are going to not this. Okay, so we are going to go into the details of machine learning, and here you can see that we'll start with simple regression, then MLR, which is multilinear, polynomial, logistics, k-means, hierarchical, and everything. Why we are doing this? So that it becomes easier to do the deep learning. Okay, the deep learning in parts is uses these techniques, and since most of the work is happening in deep learning, we would like to focus on solving problems with deep learning. But again, a lot of problems are still solved using the statistical machine learning, the standard machine learning. So we would like to cover all of that. Also, these basic techniques are used in the deep learning to feed the to create the data, to create the data samples, and so on. Okay, so in the deep learning part, we are going to start with TensorFlow, and we will learn the ANN and deep learning networks. Okay, all right. So this is going to start. The machine learning is going to start at the same time from December 3 onwards. We will first go with the introduction, and then we are going to start with a hands-on and so on. Okay, so that's the plan. All right, so a question from Node: what's the difference between free and paid course? The free course was basically for Python and Foundation. We thought that it'll be useful for all, and while the paid one is rest of the course after December 3, after the introduction to machine learning, everything is going to be paid. Okay. All right, come over to the enroll now button. The fees you can see there. All right, VKS. So, all right, so you can see the fees there. All right, you have already finished 1/3 of the course. I look forward to see you in the remaining. Bye-bye, have a good day, and stay connected with us. And we have a good, active, active discussion forum. You can ask questions there. Yes, Binta, you have a question, you have raised a hand. Also, please fill the survey. That helps me understand how am I doing and what are the areas of improvements. So please fill the survey. Great. Wonderful to have all of you in the session. A question from Binta is that could you post email the schedule of your live instructor lab for next week? Sure, sure. So you'll receive an email from us with all the details. Okay. Really, I'm very happy, Sweta, that it was useful for you. Okay. And all right, I look forward to see you all. So we are having one more session on the next Saturday from India time, and it's going to be Friday from the PST time. All right. So these two sessions have gone extra because we are doing the Python course for the first time in this format. We have extended many topics in it. That's why our expectation from Python was different. So that's why we have extended two more. And trust me, schedule is on one side, but my intention is to get your questions answered. And therefore, it's okay to go beyond 1 or 2 sessions. Okay, there is no point in finishing the topics without you understanding it. All right. So your questions are not stopping the sessions. Instead, your questions are making these sessions more helpful and more meaningful. All right. So do not worry about overflowing, and it's completely okay. All right, so that's pretty much I had to say. So stay connected, and I look forward to see you next week. Thank you, Kamal. Thank you, Dinesh. All right. Bye-bye. Have a good day. Thank you, Noor. Thank you, Admin. Thank you, Balaji. Thank you, Binta. Thank you, Dinesh. Thank you, Gaurav. Thank you, Hemant. Thank you, Henry. Thank you, Kamal. Thank you, Karthik. Thank you, Patel. Thank you, Mac. Thank you, Manoj, Prashant, PSG, Raghvendra, Raghuveer, Ram, Rameshwara, R&D, Sakti, Sarath, Sweta, Smile, and VKS. So this course is humongous. It basically is going to go for around 60 more hours. Okay, so that's why the course is costing a little higher. And yes, okay, these modules are basically a huge course. Okay, sure, Binta, we will share the update the post and slides too. Okay, but these Jupyter notebooks are available to you. Try all of the Jupyter notebooks. Please, I mean, that is the only way to retain. Before the next session, you should go to my courses. We have created a courses for all of you. This is a public free course. This is where you get Linux basics, you get lab overview, and then you get the Python course. And in the Python course, you can visit these videos along with the slides and all the exercise. Okay, all the exercises will be available here. All right, so keep finishing your assessments here. Okay, this should become 100%. All right, thank you everyone. I look forward to see you soon in the next session. All right, so Noor, the video will be made available here in your my courses in the Python course. Okay, so probably in by morning it would be available. All right, it'll take some time because it takes some time to convert it. All right, good, great. Thank you everyone. It was great to have all of you in the session. Please feel free to fill in the survey which is posted by my team, by Shahrukh, and also stay connected with us. I look forward to see you next. Okay, these are the important topics that we're learning. They are building the foundation of machine learning, and we will learn machine learning in a way that we all understand it. Okay, all right, thank you everyone. Bye bye, have a good day. Wonderful to have all of you in the session. It was very enriching for us, and we learned quite a few things. Bye bye, have a good day.